This guy is. Hold on, it's not my notes are like just when it's on.
So let's turn to our packet that you just picked up. This is your quiz review packet. Let me read number one here. So we have a cylindrical container. This feels like it's going to be like a related race problem, but this is just going to be a solving differential equation one. We have volume is changing at a rate of negative pi over 2 root h. That indicates that this is talking about dh dv dt. Given that h equals 9, solve the differential equation for dh dt. So it's a little bit of related rate in terms of we're going to find the derivative. But after that, it is just trying to solve for that differential equation. Okay. So we know that when it comes to cylinders, our radius is never changing, right? So we know we can just go ahead and replace your radius with 3. And now we can find dv dt. From here, we know we can replace dv dt with the value that they gave us in terms of h. Solve the differential equation for dh dt. So at this stage, we're going to treat h like our quote unquote y and t as our independent variable. Okay, so now we're going to work towards solving our differential equation. So we're going to find a way to get our h's together on the same side and then everything else on the other side. But ultimately, time is our independent variable. Let's see if I can get it to a point where I can cross multiply here.
I'm going to rewrite this 9 pi dh over dt is equal to negative pi root h over 2. Okay, let's see what that looks like. Cross multiply. We can get the pi's to cancel out, right? That's really. And if we want to group our variables together, we can have our h's on the left side and everything else on the right side. Yes. Oh, sorry. Yes, you're right. Okay, so when I cross multiply and I move my variables around, now I have full separation, right? My dependent variable, in this case, h is going to be on the left, and then t is going to be on the right. Now, I just want to point something out here. When you're solving differential equations, I know we're more comfortable with x's and y's, right? It's easier to feel like, okay, y is on the left, x is on the right. I think when we start seeing other variables, we may feel a little bit disoriented, like, wait, how do I deal with if it's a w or a q or a t or an h? So I want to just give you some anchor to kind of hold on to. If something is not x's and y's, it'll always be time and something else. Okay, so if you see a strange variable like a w or a q or an h, just know that is going to be your dependent variable. That's your quote unquote y, and it's always going to be paired with t. Okay. Now, in the off chance that that doesn't happen, let's say it ends up being like du over dv. It's like, okay, how do I know what's my independent variable? Your denominator is your independent variable. Your numerator is your dependent variable. Okay, so in the off chance that you don't see x's and y's or t and something else, then you have to just rely on, okay, the form that they give you. Okay, so here, this is just an example. So if you see du over dv, then understand that, okay, you're going to treat u as your quote unquote y and v as your quote unquote x. Okay. All right, but anyways, back to this problem here. I do want to get these terms ready for my antiderivative. Now, root h, what ultimately do we have to go through for this rule? Power rule, right? So setting myself up for power rule here on both sides, actually. Power rule on the left, power rule on the right. Okay, so now that we solved this differential equation, now you're free to do whatever order you want to do things in. Right? But ultimately, there's two things left to do. We got to solve for h, and we got to solve for c. So just know that if you end up not following the path that I go down, it's fine. You don't have to do everything the same way. But as long as we know that we have two goals in mind left to do, then do whatever it takes to get you there. For me, though, I just want to. Oh, sorry. I don't know what happened. Sorry, it's already It's already 2. I should be dividing by 2. Let me backtrack. This is for me, it's a fairly clean stage for me to just go ahead and take care of my C value. So I'm going to go ahead and just plug in my order pair here. They do give me an order pair of 0, 9. We know that at h equals 9, t equals 0. Again, if you're solving for C at a different stage than me, you're getting a different C value, and it's okay. Ultimately, though, at the end, we will come back into agreement. Okay, so don't feel like, oh, you're getting a different C value. That means we're not on the same page. Any questions here? Yeah, some of the more difficult differentiation problems are going to be the ones that where you don't see x's and y's. If you don't, usually time and another variable usually kind of throws students off a little bit, just because we're just not used to these variables. We wish that everything would just be x's and y's, but we do need to just be comfortable with variables other than x's and y's. So we're really spending time to practice these types of problems. Okay, number 2. The rate at which a baby koala bear gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bear is first weighed, its weight is 2 pounds. If b of t is the weight of the bear in pounds, then dB dt equals 1/4 20 minus b. Find y equals b of t. We're trying to solve this differential equation. So we're going to go through our steps. Try to separate our variables, take the antiderivative. Okay. So my first step is I need to do whatever I can to cross multiply and get my dB and dt lined up in the right spots. And then I can worry about, okay, do I need to move my variables around to get full separation? But my initial step, I'm not too worried about separation. I just want to see what I can do to cross multiply and at least get my dB and dt lined up. So I have these two locked in, right? dB and dt are nicely in place, but we don't have full separation yet. I would like that 20 minus b to be on the same side as dB, and the 4 doesn't have to be there. So I'm gonna move that 4 over as well. So I'm gonna just do a, I'm gonna do a double division, move both things at the same time, and they're both gonna end up in the denominator of the other side. Once I have full separation, I can think about antiderivative rule. Right side is power rule, but the left side, a little bit of what? U substitution with the U value being 20 minus B, which will eventually turn into 1 over U du, right? Because we see that the U value is just going to be U to the first power. But the derivative will produce a what that we got to be careful about? -1. Yeah, so that -1 is going to carry over into our antiderivative, so just be aware of that. Okay, make my substitutions. One over U du, it's just natural log absolute value of U, but we got to carry that negative through. So negative natural log absolute value of U, which turns into negative natural log absolute value of 20 minus B. So that's the antiderivative, 1 over U du. And then 1/4 dt just becomes 1/4 t plus. Right, let me reset. So once again, 1 over U du becomes natural log absolute value of U. The negative carries through. Replace the U back in terms of my original variable. And the right side is just power rule plus C shows up. And I'm done with the calculus. Right? Everything is up to the function level. There's always, at the end, after you take your antiderivative, there's always 2 things left to do. Okay, solve for your dependent variable. In this case, I need to solve for B, and I need to solve for C. Typically, with natural log, I like to solve for B first. Just feels cleaner to just get that out of the way, and then once that's out of the way, I'm going to solve for C at the end. But I want to take care of this natural log first, because I want to solve for B. I want to raise both sides with E as the base to get that natural log to go away, but this negative is kind of getting in the way. I'm going to make sure that negative distributes to the other side so that the left side is a little bit cleaner for me to work with. Technically, we are distributing the -1 to the C, but plus C, since C takes in both positive and negative values, I'm just going to leave it as plus C. All right, I want to solve for B first. So I'm going to raise both sides with E as the base. By the way, if you solve for C first, that's perfectly fine. You're getting a different C value than me, but in the end, we should be in agreement. If I separate the exponents, I could get e to the -1/4 t times e to the c. Drop the e to the c. Well, replace e to the c with what? C. Okay. Absolute value gets dropped. Plus or minus shows up. And we know the plus or minus get absorbed into the C. Okay, let me solve for B. So at this stage, I feel it's a little bit cleaner to solve for C here rather than before. Now that the natural log is all out of the way, so now I'm going to take my order pair that they gave me and solve for C. So at time t equals 0, the weight is 2 pounds. So So 2 will plug in for B, 0 will plug in for T. We know that negative 1/4 times 0 is 0. E to the 0 is 1. Now I can solve for C here. So I have my final solution solved. We started off with something at the derivative level, dB over dt. We were able to take the antiderivative after we separate our variables. And then once we got everything up to the function level, we had to take care of 2 more things. Find a way to solve for C, find a way to get your dependent variable by itself. And it doesn't matter which path you take after that, we should all be in agreement when we come to the end.
You should also write it as negative 18.
Sure. Yeah, the order doesn't matter. If you have the constant coming after the variable, that's perfectly fine. Okay, number 3 should feel a little easier. Just asking you for tangent line equation. So remember your differential equation is just a fancy word for derivative. Okay, it looks messy, but it does the same thing as other derivatives. You give it enough information, it'll give you a number. That number will be the slope. So this is linear approximation. Let's focus our attention on trying to find the tangent line first. And then once you get that tangent line equation, then the 2.2 plugged into the linear equation will give us our linear approximation. Part A won't take up a lot of space because you're just going to plug the 2, 0 into the derivative to get your slope, point slope form. So, and I need to give you more room for part B. So just know that part B will take more space. So whatever space you can save for part A, maybe you can just use a portion for part A, and then for part B, you got to solve the equation. So you may want to bleed into, use part of part A for your space. Okay, so part A hopefully feels pretty straightforward, right? Change sign equation, plug in the decimal. Okay, part B, now we're solving differential equations. So we're gonna go through our full process here. Cross multiply. Again, keep in mind your parentheses. If they give you parentheses for a differential equation, they're trying to help you separate the variables. Okay, so usually we don't want to expand and distribute because then we lose the. We're gonna go back to where we came from. So if they give you parentheses, they're trying to help you keep things separate to make it easier for you to separate your variables. Once we have our separation of variables, meaning the y is on the left, x is on the right, we know that this e to the y is out of place, right? We don't have a rule that can handle e to the u in the denominator. So we got to push it up to the top, make that y a negative so they can get that form e to the u du, which means that when you go through u substitution, there will be a negative that's going to come out of that process. So this should be where we're at before we jump into our integral rules. Power rule on the right, a little bit of u substitution on the left. So I took the antiderivative, went through u substitution. I'm going to distribute. I'm going to solve for c at this stage. So my order pair is 2, 0. So 2 in for x, 0 in for y. So once I solve for c, I'm inserting it back into my original equation, and then whatever it's going to take for me to solve for y, I'm going to start off by making that negative go to the other side first, multiply everything through by -1. Take the natural log of both sides to allow for that exponent y to come down. Let the negative y come down in front. Almost done. Distribute the -1 through the parentheses so I can get y completely by itself with a positive y, so the negative gets transferred over to the other side. All right, next page, number 4. Okay, very much the same process here. Write the equation of the tangent line, so, and do a linear approximation. So we're not solving anything here. You're just using the differential equation to get to your slope, point slope form. Try part A. Okay, so my dy dx is my slope formula, my derivative equation. Plug 0, 4 to get my slope. Take my order pair, my slope, point slope form, get my tangent line equation, plug in the 0.6 and get my linear approximated value. Part B, find the value of d2y over dx2. What is this asking for us to find? Find the what? Second derivative, right? We already have the first derivative, so just have to go one derivative down. So d2y over dx2, 6 turns into 0. What does minus 2y turn into? Minus 2, yeah, minus 2 dy dx, right? We're basically, it's basically implicit. You have y's in the equation, the derivative is going to have to. So once you find our derivative, we can replace the dy dx back in terms of dy dx, because we know dy dx is 6 minus 2y, and now we can get our second derivative in terms of x's and y's. Plug in our order pair, and that number is going to tell us the concavity, right? Positive second derivative will be concave up, negative second derivative will be concave down. Part C, let's solve our differential equation. So now we go back to part A. Now we can use that differential equation to do all the process that we've been practicing, right? Separate the variables, take the antiderivative. Yeah, the thing that's a little bit more challenging with differential equation is there's just a lot of algebra. Once we get past the antiderivative stage, we still have to go through a bunch of algebra to solve for C, and then there's that solving for Y. On the test, on the quiz, I will give more priority to the calculus. I will make that the worth more. So if you're making a slight mistake at the end with the algebra, that's not going to be worth as much. Okay. And same thing on the AP exam. They're going to prioritize your calculus steps over your algebra steps. I mean, obviously they'll still take off points if everything's not correct, but the emphasis and the weight of the problem is mainly on the calculus procedure, right? Are you able to separate the variables? Are you able to identify the appropriate integral rules? If there's use substitution, can you go through that process? But at the end, right, the algebra is a little messier, and it's understandable when students are making mistakes over there. So don't get too stressed out about that. It's not like you're going to lose the majority of the points because you missed out on the C value. You forgot a plus or minus here. That's you're still going to get the majority of the points if you can get the process right. So
after we separate our variables, our y is on the left, x is on the right. We definitely go through u substitution. U value is the entire denominator, but the derivative will produce a negative. Not only a negative 1/2, it'll produce not only a coefficient, but a negative as well. So as we go through our u substitution steps, we understand there's a negative 1/2 in front. 1 over u becomes natural log absolute value of u. I decided to clean up and solve for y first. Or at least I think, no, what I did was I cleaned it up to a stage where it was easier for me to solve for C. I went ahead and I solved for C, and then I went back and I solved for Y. I feel like sometimes the things I do doesn't really have a rhyme or reason. I think it's just, at certain stages, I feel like, okay, I find that this is a little bit easier to do, maybe a little bit less messy. And so I'm kind of like going down the path of least resistance in terms of, okay, it feels easier to solve for C here. Before I got to do a lot of, there's less calculations to do. So, but I think the big picture is once you solve your differential equation, you decide how you want to get there. When do you want to solve for C? When do you want to solve for Y? But there's no one way to do it. If you can turn to page, I didn't put page numbers on here, but if you can turn to page, the next page, page 3, just want to point out a quick problem here. Number 9 at the bottom of the page. Number 9 says, for what value of k will this equation be a solution to the differential equation? So the strategy for these problems is from y, go ahead and find y prime and y double prime. And from there, you can take all that and take everything that you find and insert into your differential equation. And then you should be able to solve for k. Just treat k like a coefficient. So you'll find y prime, cosine of u becomes negative sine u times u prime, sine becomes cosine of u times u prime. Once you find your first and second derivative, go ahead and replace y double prime and y in terms of what you found. And then you should be able to solve for k. So your homework will be pages 1 through 4. I'll be checking, we got through a good portion of page 1 and 2. So you should be to finish the rest for homework. I'll check that on Wednesday. I'll also send you a link to the key so that you guys can check your answer. But it's basically on the differential equation page. But yeah, I'll send out a reminder tomorrow afternoon. So we'll have Wednesday to continue reviewing. Thursday, I'm going to start 8.1, but we can still spend a little bit of time to review. I may have a help session Thursday morning, and then Friday will be your quiz. All right, come get your phones.
Mr. Yang, we have
At most 8 to 10 points.
Gonna be that bad.
Yeah.
So I think you got it. Yeah. I think
Sort of,
it's something you have to.
But it's more interpreting, and you interpret.
Mr. Yang, I know the first of this year I'm missing. I had to bounce. I went past what was I missing, so I can all three items.
Oh.
We keep this.
No, it's not. I don't have anything that you're missing for this
So you know, let's get in.
for unit 7, right?
Yes, I mean, it was last, it's not, we were doing unit 7 last week, right?
Yeah, FRQ 3 to 4, page 6 and 7. I don't have you having any issues.
Oh, okay. I thought,
Actually, I have to come back. Which is pretty cool.
Nathan, do you have your homework?
Yeah. That's the little. I give this man a bit of 5.5 out of 10.
yeah, that's the trap.
Oh.
I'm not thinking it's 7.
Oh, you're about average, or maybe a little worse, maybe like 4.8.
4.8, okay, it's been good.
Yeah.
I mean, I'm pretty satisfied with that, given that you gave him 5.5. So is it like, so if you're, it's still good.
I was average.
Okay,
And that's really good. And it's literally the best
You should be off.
thing I've ever seen.
That's fine, yeah.
Put it in the cost of thinking about it.
Yeah.
You get that
So
today.
your request to have your
Yeah,
homework.
the trees like that.
Just wanted to point out some patterns.
If I
that I
get
see.
to a 5.5, then that's good.
You know, it seems like you're having trouble
Exactly.
each day with
The
that.
fact that I'm giving you above average is like.
It's on the zeros.
And I just want you to be okay if you don't meet that
You're
goal,
like a-
right? That's a pretty lofty goal. I mean, you have trouble
Like
catching
oh,
on.
1.6.
And for you to,
You're not
you know,
terrible, but like,
feel like
you're obviously not.
you're gonna want to fight for
Yeah.
that, but, you know, it's tough. Right? I mean, I don't know, maybe you have so much going on that you can't finish your homework sometimes, or maybe it's a time management issue. But, you know, when you're doing your homework in class, you're missing out on content, so you're missing out on content, you're putting all the pressure at home.
Like I did it.
Didn't pull up
For the whole thing.
So you're
Oh, yeah, he didn't go.
I did on my computer.
Okay.
Oh, yeah.
And then I printed it out and I just like I did it so. That's why I was able to do so quick. I remembered exactly what I did.
Well, in the future, if you know that you have trouble keeping track of it, just take photos of it. That way it's always on your phone. And you misplace it. As long as I see it on your phone.
Yeah, I had it. I have a picture, I'm pretty sure.
Okay.
You stole normal.
Right. Well, then you have to go through and rework all these problems then.
You ever get something this day? This day you'll.
It's only $1.
Do you actually know how to do it?
$1.
It's the thing, it's plenty of.
Always. What? Oh, that's like.
Did you ever get some of that?
It's like, oh, it's a practice, right? So I'm like, there's gonna be a lot of people.
He's getting.
Yeah.
No, yes, they're putting in.
Absolutely. Which section? The violin is something itself.
Would you get? If you're. That's it, you'll be so cool. Hey, real thing, you'll be.
Last thing for me, that's like.
Senior items, and I'm joking, I'm calling them the thing you'll be. You know, like Bacon's Revolution. I'm gonna go. Then you'll be.
I'm sure like pretty. I was like 95 on this quiz.
Yeah, I'm aware. Didn't. From my solution.